So last time we started working with arrays, and we are at lesson 14. Let's see another example with an array. I'm defining this variable animals, which is an array, and in this parenthesis, I'm giving the values of the array. Now, because I'm using this double quotes, this is a single value. This is considered a single token by the shell. It is not split by this empty space. And this is another value, and this is another value of the array. And we saw last time that I can get the first value in the array like this. So this is the index of the first item in the array, or the second item is this one. And if we want to get all the items in the array, then we can use this star. But let's use a for loop to get the values one by one and to print them in order to understand better how we are getting all the values. So for I in all these values of the array, do echo I done. So what is happening in this case? It is that it is getting all these values. This for loop is getting all these values, but the shell is splitting them by the empty space. So for is taking this one first. So I is getting this one as the first value, and then it is getting this one, and then this one, and so on. So how can we fix this, or what can we do to fix it? Let's try with this @ sign instead of star, because it also means get all the values of the array. And again, the same thing is happening. But let's try to use double quotes. If we surround this in double quotes, now what is happening is that all the values of the array, which is this one, is actually surrounded by double quotes, and it is considered as a single value. So I is getting just one value, and it is being printed, and that's it. So we are not getting all the values of the array again. But let's try surrounding with double quotes this one. Now we are getting all the correct values of the array. So if we have an array and we want to loop through its values, to take these values one by one in a for loop, then we should use this construct. So use this @ sign as an index to get all the values of the array, and surround with double quotes the array. And then we will get all the original values of the array. And this is similar to what we have seen with parameters, positional arguments. So with positional arguments, this is the first argument, this is the second argument, this is the third argument. But if we use a star, then it means all the arguments. And all the arguments does not respect, if an argument contains an empty space, then it will not be considered as a single argument. It will be split in two arguments. And if we surround it with double quotes, then all the arguments will be considered as one argument. But if we use this double this at sign with double quotes, then we will get all the original arguments one by one, even if the arguments contain an empty space. So it is similar to this one. So this is acting like an array in this case, or they are just similar. Now let's see how many elements are in a given array. For example, I'm declaring this. Which means that this is an array, and in this array, 101, because it starts from 0. In this position, there is this element, or this item, this value. There is this value. But all the other positions are empty. There are no other positions. It has just one position. So if we want to get the number of items of the array, so this is the number of items. With this hash in front of the name of the array, we get the number of items. It has just one item. And if we actually do it like this, this is the length of this item, of the item in this position, in this index. And the length of this item, the item in this position is this one. And its length is 7, because it contains 7 characters. So if I use an index and I use this hash in front of the name of the array, then it is giving the length of the item in this index. But if I use this @ sign as an index and use an hash in front of the name of the array, then it is giving the number of elements of the array, or the number of values of the array. And also, if we remember from the positional arguments, this is the number of positional arguments. So if a script has 3 arguments, then this special variable has the number 3. So this is the number of positional arguments. And let's see an array that has indexes, sparse indexes. So let's say foo is an array, but now in the position 2, we set the value A. In the position 4, we set the value B, and at the index 6, we set the value C. So the position 0, the position 1, the position 3, they are undefined, or they are empty. But at the position number 2, we have stored this value. At the position with index 4, we have stored this value, which is a string. At the position number 6, we are storing this value. So let's try to display all the values of the array. So these are the values of the array, and it is the same with star. And how many values are there? There are 3 values. This is the number of values stored in the array, or the length of the array. And if we use this one instead, this exclamation point in front of the name of the array, then we are actually getting a list of the indices of the array. So there is a value in the index number 2, there is a value in the index number 4, and there is a value in the index number 6. And with this exclamation point in front of the name of an array, we get a list of indexes of the array. With this one, we get all the values of the array. And if we use this exclamation point in front of the name of the array, we get all the indexes of the array. We can append some more values to an existing array. For example, if we have this array that has the values A, B, and C, so this is the array. Let's see its values. They are A, B, and C. And now if I want to append some more values to this array, I can use plus and equal, and then another array. So this is like append this array to the end of this one. And if we check all the values of the array now, we see that these values are appended to the array. If we want to sort the values of an array, there is no predefined function or a construct in Bash, but it is easy to sort it using the existing tools. For example, let's see a script that is sorting an array. We are defining an array with the name A, and it has these unsorted values. So echo we are displaying the original array here. Let's test this. So we are just displaying the original array. Now let's continue to edit the script, and we will try to sort this array. This is another array, A sorted, and here we are going to define some values, and these values are going to come from this array, but we will sort them. So we are executing a command here for I in all the values of the array I, do echo I, and then done. So we are getting all the values one by one, but now we are piping the output from this for to the command sort. So this for is sending to the standard output all the values of the I array one by one, and then this sort is sorting them. We are piping them to the command sort, which is sorting these values. And the result of all of this command will be saved into this array as another array, and it will be sorted. So let's print also this array. So we see that the second array is sorted alphabetically. And another way to sort the arrays, so we can make it simpler, or we can use another way, maybe not simpler, but another way is like this. So let me comment this. And now I can use echo instead, which is going to print all the values of an array, but in one line. So let me delete the rest of the for command. So it is going to print the values of the array, but in a single line. And sort does not work like this. Sort is sorting all the lines. So it is sorting different lines. It does not sort the values in a single line. So we will convert the values that are in a single line so that they are in different lines. And we can do it with the command tr. And we will substitute an empty space with a new line. So an empty space which separates the values from this command will be converted to a new line, so that each value is in a single line, and then the sort command can sort them easily. So let's try this one. So this one works as well. So we can use these two methods, or maybe some other ones, to sort some values of the values of an array. To delete an array, we can use the command unset, which is also used to delete a variable in general, a shell variable. So let's see what we have at foo. Foo is already defined, I think. Yes, we have an array in the variable foo. Now, if I do it, unset foo, and then try to display again the values of the array, there is nothing. It is empty because this is undefined variable. Unset will just undefine this variable. So it will throw away its value and undefine that variable. Sometimes it may be needed to delete just one value from the array or just some values, not the whole array. So let's define this array again. So we have this array. And let's say that we want to unset or to delete this value. It is in the position 2. It has index 2. So usually we will display its value with this. But now we can say unset. And this is the name that we use to access this value. Now let's display the whole content of the array. And we see that this value has been deleted. It has been removed. And we have to use these single quotes. Otherwise, this will be interpreted. These square brackets will be interpreted by the shell as a file substitution. So it will try to match a file with this name in the current directory. So in this case, we have to surround the name of the variable with these single quotes. And so we have this value in the array. But what happens if we do this one? So we may think that we are assigning an empty value to the array. But let's check what is in the array. And we see that actually we have undefined only the first value of the array. And why it happens like this? It happens because if we don't use any index, we just use the name of the array, but without an index, it is interpreted as the index 0. So the item in the first place of the array. So we are just telling it to unset the value of this variable. So this is the name of the array without an index is interpreted by the shell as the first item in the array. So this one will just unset the first item of the array. And if we say, for example, so let's display the values of the array. We have these values in the array. So if I say foo, so I'm not assigning a value to the whole variable, to the whole array, but I'm assigning this value to the first item of the array. So without an index, it is interpreted as the first item of the array. Now, all the arrays that we have seen so far have numeric indices. So index 0, index 1, index 2, in the position, in the first position, in the second position, in the third position, and so on. But it is possible to use also associative arrays in Bash. Associative arrays are arrays that have indexes that are not numbers but are strings. So let's see an example. To use an associative array, we have to use this keyword declare with the option capital A. So this is declaring an associative array. So this is the name of the array, and it is an associative array. Now let us assign some values to it. Colors red, for example, gets the value colors blue and green now let's say that we want to get one value of the array. So we are using this as the index of the array. And again, if we want to get all the values of the array, then we do this. And we are getting all the values. And if we want to get indices instead, then a list of indices, we use this exclamation point, and we get index red, blue, and green. So a list of indices of the array. Now that was it about the arrays. Now let's see another topic. We will see group commands and subshells. So group commands are commands that are delimited by these curly brackets. For example, command 1 semicolon, command 2 semicolon, command 3 semicolon. So we have a group of commands which are surrounded by and subshells are similar, but we use parentheses. Command 1, command 2, command 3. Notice that we have to use an empty space here after the opening curly brace, and also another empty space here. Otherwise, the shell will not interpret correctly. And also, we have to terminate the last command with a semicolon or with a new line. So this is actually like the body of a function. So when we define a function, this is a body of the function. So it can be thought as a no-name function, a function without a name, or an anonymous function. And this is actually executed in the current shell, and this is starting another shell. So this is why it is called subshell. So it is starting another shell, and it is running these commands in the new shell, in the subshell. And we will see why it makes a difference, or how it makes a difference. But first, let's see an example of using group commands. And group commands are used to manage of output or the input, but usually the output. So let's see that we have this. I'm creating just a file. Which has the current date and time. And now I will do these commands. Output. So the output of this command is redirected to this file. And now another command, listing and I'm appending to the same file. And now another command, and appending the output again to the same file. And this file now looks like this. So what can we do instead is we can start a group command and do the first command, which is this one, and then the second command, and then the third command, and semicolon. So this is a group command, and redirect the output of all the commands to output.text. So by grouping these commands, we make possible to redirect the output of all the commands inside the group to the same file. So this is one way where we may need to use these group commands. It is similar with subshell. So I'm starting subshell here, and I am closing it here. So in the case of subshell, we don't need to leave an empty space around the parentheses, and also the semicolon here is not mandatory. So it gives the same result. The difference is that these commands are executed in the current shell with subcommands, and with the subshell, a new shell is created, is started. A subshell is started, and these commands are executed on the subshell. And in some cases, this does make a difference. And this is more efficient because it is executed in the current shell, and the subshell is less efficient because it has to start a new bash program and run these commands into the new shell. And redirection can also be done by a pipe. So we can redirect the output of a group of commands through the pipe to another command. For example, I was trying to redirect to the command less. So we can redirect the output of a group of commands through the pipe to another command. Let's see an example that is using arrays and also groups of commands. This script is using arrays to tally file owners. Here we are declaring several arrays. This is one array, another, the third one, fourth one, and the fifth one. 5 arrays, and we are declaring them as associative arrays. First of all, we are checking whether the first argument is available or not. If it is empty, then we display the usage. We need a directory as an argument, and then exit with an error message. So this script expects a directory as an argument. And now we do a loop, and this is a list of the files in the directory. So this is the name of the directory, and this is matching all the file names in the directory. So this is a list of the files in the directory, and we are looping through all of these files. And with the command stat, we get statistics or status for this file, and we the owner. We extract the owner and store it or save it into this variable owner. And the same for the group. We save the group of the file, the group to which the file belongs, to this variable. And now this is an array. At this index, we store the file name. So the file name is the index, and the file name is the value. In the array file owner, we use the file name as index, the owner as the value. And in the array file group, we use the file name as the index and the group as the value. And we also have this other associative array, but we are using the name of the owner as the index in this array. And for each file, and we look at the owner. We look at the owner of the file, and we increment this value. So this is counting how many files belong to an owner. So for each owner, how many files they have. And this is very similar. It is counting the number of files for each group. So how many files belong to a group. And this is collecting and processing information. And now we are displaying the information that we collected. So list the collected files. We get all the values in the list of files, and then we are printing 3 values. We print the file name itself. We print the name of the owner of the file and the group of the file. And we are sorting the output that is coming from the command for. So we are using these group commands so that all the output that is coming from printf is collected, and it is redirected through the pipe to the command sort. So the effect of this group command is to collect the output from the commands inside, and the command printf is printing some output. This echo is just leaving an empty line, and then we print the list of owners. So this is like a header, file owners, and then again a for loop, and we are looping in the indices. We are looping in the indices of the associative array owners. So for each owner in the list, we print the owner itself, and we print the number of files that belong to this owner. And again, the same thing here. The output of the command printf is collected by this group command, and through the pipe it is directed to the sort command, which sorts it alphabetically by the name of the owner. And exactly the same thing is done for the groups. So in the index, in the list of indices of the groups array, we print f, what we are printing is the name of the group and the number of files that belong to this group. So let's try this script. First, without an argument, it is printing the usage. So the name of the script, and it needs a directory as an argument. So let's give it a directory. It is processing. It is reading the files in this directory one by one. It is processing them and storing the information in the associative arrays. And finally, we get a list of all the files here. This is the list of all the files and the owner and the group for each file. But at the end, we also get a list of file owners. Actually, all the files are owned by the root, and there are this many files owned by the root. And file group owners, this is the list of groups. This group has one file. This group has one file that belongs to this group. There is one file that belongs to this group. Files, these many files belong to the root group, and 2 files belong to the shadow group. So this printf here, this printf command is taking this format. So the data are printed in this format, and this -10s, I think it is getting 10 spaces. This minus maybe is left aligned, so it is aligned on the left, and this percentage 5D, it is printing a digit, a number. It is printing a number, and it is taking 5 characters, 5 places to print the number. And okay, let's look again. Yes, it is aligned on the right. So this minus makes it aligned to the left. Now let's see another example that with the read command, and we have seen before that it doesn't work; it fails. But let's see it again. So we are trying to redirect some output from the command echo to the command read. And now what is on the variable reply? It is nothing. Why? Because it is because of the way that the pipe works. So when the shell seeing this pipe, it is creating a subshell to run this command. So this command is being executed in a subshell, and it is getting this input, and it is storing it in the reply variable, but it is the reply variable of the subshell. And once the command is executed, the subshell is erased, and all the variables inside it are erased as well. And this reply variable that we are trying to print here is the variable reply of the current shell, and it is unset. So this is why this does not work. But there is a way to kind of fix it. We can fix it somehow, like this. And echo reply. Now, what is this kind of strange thing? It is called a process substitution, and it is behaving like a file. So it is getting the output from this command, and it is making it available as a file. And now, because it is behaving like a file, we are redirecting redirecting the standard input from this file. So we are reading actually from the content of this file. So it behaves like a pipe in reverse, so that usually the pipe has the command that produces the output is on the left, and the command that gets the data is on the right. But this is happening on the other direction. The command that produces the output is on the right, and the command that gets the output is on the left. But the important thing is that this read command is being executed in the current shell. And because it is being executed in the current shell, the variable reply in the current shell has the correct value. And let's see what happens if we try to echo this. So if we echo this one, what we get? We get this dev fd63, which is like a file name. So it is behaving like a file. And this is the identifier of this file. So this is a process substitution. So in general, process substitution is like this. And here we have a list of commands. And the output of these commands is being treated by the shell as a file. So it is possible that we can redirect the standard input of one command to read from this file. So another case of process substitution is like this. And here we have a list of commands. And now in the other direction. So we can send some output from this command to this list of commands. So the commands here are reading some data from the output that is provided by the command on the left, similar to a pipe. This example has a usage of this process substitution. So we have a while loop, and we are reading some variables, and we process these variables inside the body of the while loop, and the processing is just printing them, just printing these variables. But at the end of the while loop, we have this standard input redirection. And instead of reading from the keyboard, the command read is reading from this file. It is being considered as a file. That's why we are using this file redirection, so that it is reading. It is like reading input from the content of a file. But actually, it is not a file, but it is the output that is provided by these commands. So this command is listing the content of the directory given as the argument. So this is the first argument. And then it is taking only two of them. So the command tail is taking the last two values. So if you try pro, so for each file, it is printing its details in this format. So can we use a pipe to redirect this? Maybe we can do it. Let's try. So let me copy these commands and then pipe them to the while command. And here just done, and I'm commenting this one. So let's try this one. So we are running the command ls, and then we are piping it to the command tail, and then the output of the command tail is piped to the while, and then inside the while we have this read command. Yes, this also works. So these two are kind of equivalent, but instead of placing the commands that produce output on the left and the commands that consume the output on the right, which is the case with the pipe, the command that is consuming the output is on the left, and the command that produce the output are on the right side, and we are redirecting it like a file. Now let's see another subject or another topic, which is traps. So when we can send a signal to a program that is running, we can send a signal to it with the command kill, for example, or with the command control C if it is running in the current shell. And the program will respond, will receive this signal and will respond to it in some way. So if we send the command control C, we expect it to be interrupted, so it will stop itself. We can also make shell scripts to intercept the signals that are sent to them and to do something when they receive a signal. So let's see an example like this. So this is a signal handling demo. And to intercept a signal, we can use the command trap. So we want to intercept, for example, sigint and sigint and signal terminate. And if one of these two signals is sent, then here we do something. We tell what to do here. We do something here. So what we are going to do here, we just run the command echo. So we just ignored, we are printing this message that we are ignoring the signal. So in this case, we are just ignoring. In some other case, we can terminate. For example, we can write just exit here and it will terminate the script. But in this case, we are just choosing to ignore the signal. We are intercepting it, we are handling it in the script, but the handling that we do to the signal is just ignoring it. So we just define this trap here at the top of the script, and now the rest of the script is, for example, a simple for loop for I in 5. So it is just printing a message, and then it is waiting for some time, for example, for 5 seconds. And this is giving us time to press the Ctrl+C to send one signal to the script. So let's make it executable, and let's run it. So I'm pressing Ctrl+C, and when I press Ctrl+C, I'm sending a signal to the running script. But the script intercepts this signal with the trap command. Intercepts this script, this signal with the trap command, and it is doing this one. It is instructed to do this echo and this message. Instead of declaring like this what it should do, what the script should do when it receives a signal, it is more convenient to define a function and to call the function here. Just call the function, and when you receive this signal, just execute this function. So that is more convenient. So let's see another example that does something like this. So this is again a simple signal handling demo, and here we are defining these two functions: exit on signal sigint and exit on signal sigterm. And this is displaying this message to the standard output, and then it is exiting. And in case this function is executed, then it displays this message, script terminated, and stops the execution of the script. And now we define this trap. If we get the signal terminate, the signal interrupt, then execute this function, exit on signal trap. If the script will get the signal terminate, then it is going to execute the function exit on signal terminate. And the rest of the script is the same. We have just a loop that is taking some time, and it is giving us time to press Ctrl+C to send these signals to the script. So let's Let's try this script. So it is running the loop. It is waiting for 5 seconds, and now I press Ctrl+C. When I press Ctrl+C, I send one of these two signals, either interrupt or terminate. I'm not sure. I don't remember, but it is interrupt script. So it is sending the signal interrupt. Because it is receiving the signal interrupt, then it is running the function that is defined for this case, and it will print script interrupted, and the exit will terminate the execution of the script. Without exit, the execution of the script will continue. So if I comment out this exit, the function will be executed, but it will not interrupt the script, and the script will continue to be executed. So I press Ctrl+C. The script will still continue to be executed. Now, in Bash scripts, we can also manage asynchronous execution. Asynchronous execution means that two scripts are running in parallel, and they communicate somehow with each other. So they can manage to communicate with each other. And the command wait can be used for this. For example, one script can wait until another script. One process can wait until another process is finished executing, and then it can continue. So let's see an example. We have two scripts: async child and async parent. This is a very simple script. It is printing this message: child is running, and then it is waiting for 5 seconds, script 5, and then the other message: child is done, exiting. Now let's see the other function, async parent. It is printing this message: parent starting, and then we are launching the child script from here, and because of this ampersand, it will run in background. So it will run in parallel with this script. So the execution of this script will still continue. It will not wait until this script is finished and then continue. So they will run in parallel, and this $exclamation point gives the process ID of the last command that is executed, in this case of this script, and we are storing it into this variable PID, process ID. So this is the process ID of this script, and then we print this message: the child with this process ID is launched, parent continuing, and then we wait for 2 seconds. Remember that this was waiting for 5 seconds, so it is still running. After this command is finished, this script is still running for 3 more seconds. And then this message: parent pausing to wait for child to finish. And then we use this command wait, and it takes the process ID of another process, the ID of another process as an argument. And at this moment, this script will be waiting for the other script to terminate, to be finished. And once that script is finished, then it will continue with these two other messages, to print these two other messages: parent, child is finished, continuing, parent is done, exiting. So let's try to call this async parent. So parent starting, parent launching child script, child with this process ID is launched, parent continuing, and the child is running. Pause to wait for child to finish. then after child is done, then the parent script will continue. Child is finished, continuing, and parent is done, exiting. So without the wait command, then these two messages would be printed before the child is finished, because child takes longer than the parent to execute. So let's try it. Let's comment this one. And try it again. So the child is terminated later than the parent because it takes longer. It takes 5 seconds. And the script parent does not wait for the child to terminate, but it does its job and it is finished. And the child script continues to run in the background. But in this case, because of the wait command, here at this moment, the parent child is waiting for the child to finish, and after it is finished, then it continues to run. So let's continue next time. We have some small topics to finish this course, but we will continue next time.